Alright, question number 10 says, on the 1st of November 2015, there were 4,200 trees that were planted in a wood, and on the 1st of November 2016, only 3,948 of those trees were still alive. Nice bit of information. It's assumed that the number of trees still alive is given by this formula, n equals AR to the power of T. That means n equals A multiplied by R to the power of T, where n is the number of trees still alive T years after the 1st of November 2015. So what they're asking us to do in part A is to write down the value of A. And to do that, we need to read this part of the question again, right? So we're looking at the 1st of November 2015. There's no difference between this date and the date that we've got in the original part of the question, the first sentence up here. So we're looking at the value of T being nothing because there is no difference between these two numbers, 2015, 2015, 1st of November, 1st of November, both the same. So no difference. So T equals 0 in this part of the question. So I'm going to write that down for you. T is nothing. And then N is the number of trees still alive. So this is on the 1st of November 2015. And that we've told that is 4,200. So N equals 4,200. That is an equal symbol again. So you're going to put in 4,200 is equal to A, and then we've got the R, and then we've got the power of 0 that we can substitute in there. Now what you have to remember here is that anything to the power of 0 is equal to 1. So what we have to do is make this part, the R to the power of 0 equals 1. So we get 4,200 equals A multiplied by 1, and A multiplied by 1 is just 1A. So the answer would be A equals 4,200. I'll just jot that all down for you. Don't need to do all the writing down, you just have to write the answer in here of A equals 4,200. Okay, it's fairly tricky because it's a little bit awkwardly worded, this question. Right, so 4,200 is the answer to part A. Part B asks us to show that R is 0.94. Now that requires us to do some more substitution and think about what values we need to use to do this. So we've used the first sentence worth of values. Let's look at the second sentence in the question. It says on the 1st of November 2016, only 3,948 of these trees were still alive. So that's the bit of information that we can use to work out the answer to this question. So what we do is we can write the formula down. So n equals a r to the power of t, and then we're going to look at what numbers we can substitute into what parts of this formula. So n, so we're looking at 3,948 would be the number that we use there, 3,948 for n. A, well, in the first part of the question, part A, we found out that A is equal to 4,200. And in the sentence up here, we can work out that T is equal to 1 because 1 year is the difference between 2016 and 2015, 1st November, 1st November. So exactly 1 year is what T is. Now we've found out what those are, we're going to be able to show that R is equal to 0.94 and substitute those in. So we've got 3,948 is equal to 4,200 multiplied by R to the power of 1. Now R to the power of 1 is just R. So and to get rid of the 4,200 on this side, because it's been multiplied by R, we're going to divide by 4,200. So we take 3,948 that's still on this side, divide both sides by 4,200, and we're left with R on its own. So if we get our calculator and type this in, we should be showing that R is equal to 0.94. So I'm just going to bring that calculator in, do the calculation. So 3,948 divided by 4,200 equals 0.94. So R equals 0.94. We've shown what they wanted us to do, and that's the working that gets us the 2 marks on this question. Part C says that show that on the 1st November 2030, which is 15 years after the original date that we're given, the number of trees still alive is predicted to have decreased by over 60% compared with the 1st of November 2015. So 3 marks available for this question. You've got to be thinking about, now we've been given all the numbers in part A and part B that we need to use. And we don't know the total number of trees that are left. So that's the thing that we're going to have to work out in 2030. So if we write down n equals, let's use a r to the power of t again, there's our formula that we were given. We can substitute the numbers in. Now we're told that r is 0.94, which is fantastic. So n equals, and we're told that a is 4,200. So 4,200 multiplied by 0.94, and then we know that the difference between the years now, because we've got 2030 and 2015, is 15 years. So we're going to put to the power of 15. Compound depreciation question is what this is. So you get your calculator and you type that into your calculator as it looks, exactly like that. You've got your scientific calculator, you can type it in. This one's a bit more awkward, but let's find out if it works. So 4,200 multiplied by 0.94 to the power of 15 equals, and I've got an answer for the number of trees, 1,660 point, and I'm going to round it, and you shouldn't round it at this stage, but I'm going to have to, because I'm not writing all those numbers down. I'm going to put 0.23, so 1660.23, 1660.23, and there are, okay, there would have been more numbers after that, but I have rounded it because I can't be bothered to write all the numbers down. So that is the total number of trees that we've got, and there's not a whole amount of trees, which is a bit awkward, it's a bit annoying, but that's the way it works. So that's the total number of trees left in 2030. Now to show that the trees that are still alive has decreased by over 60%, we have to work out the percentage decrease that has occurred. So we take this value and we work out the difference between this value and the original value, and this is how you do a percentage, working out a percentage change. So 4,200 minus 1660.23, remember I rounded that off. Okay, let's work that out. So 4200 minus 1660.23 equals 2539, I think that was, that went quickly. And find what the decimals were, 0.77. So you put the difference over the original and then multiply by 100 to work out the percentage change, and that will work out for you the answer to this question, or what we want to show in this question. So I'm going to divide that by 4,200, and that equals, and multiply by 100, that equals 60.47. And remember, your answer will be slightly different and more accurate because you haven't rounded at the stage that I did. But I'm going to round that again because that's enough for us to show that this is the percentage decrease that is over 60%. Okay, so which is more than 60%. Okay, this is the decrease. So we've shown through the maths that we've satisfied this question and got 3 marks.